Are you ready?
Yep.
Yep. Good afternoon. I'd like to introduce our next speaker, Rejean Picard, Farm Production Extension with Manitoba Agriculture. He graduated from Laval University with a degree in Applied Sciences, Soils and Crops. He started as an agricultural representative with Manitoba Agriculture in 1988 in Somerset, and he is currently working in the same office as a Farm Production Extension Specialist on the cereal grains team for Manitoba Agriculture.
Thank you. All right. Good afternoon, everyone. Yeah, so you know how long I've been around. So I've been around for a little while, actually 31 years very soon here in the next couple of weeks. So this afternoon's presentation here, I have only a few minutes. It's going to be a bit of an introduction to the next speaker. The next hour is basically about Fusarium head blight. So this is going to be a Manitoba perspective, the window of application for Fusarium head blight. So I'll have three segments here. The first one will be a little bit of history. I won't spend much time on that. And some research, that's where I want to spend most of the time. I guess that's where it's most meaningful. Some small plot trials done in the last couple of years, and also some field scale trials that have also been done in the last couple of years. And a short word on future research. So Fusarium head blight, again, it's a fungal disease affecting cereals. It's the predominant species in Manitoba is Fusarium graminearum, however you say that. Causes yield losses and affects grain quality. I'm sure most of you will be familiar with that we've had over the last number of years. And it also can result in the accumulation of a toxin referred as DON, or deoxynivalenol, or vomitoxin. So this is what it would look like in some wheat heads here, depending on the amount of infestation or infection on the heads. So they can be only if one or two florets infected right up to the whole head infected here. So, and typically the infection looks like a pinkish stain on the head itself. So I wanted to show this picture here. This is a 2000 picture, and this is the variety Cadillac. Has anybody grown Cadillac here before? This is going back, oh, not too many, eh? A couple, okay. All right, so this is Cadillac, and you'll see here there's a split here on the left side of the screen versus the right. And back in 2000, they really were still in the early years of using fungicides, because 30 years ago, hardly nobody used fungicides on cereals. But since the onset of Fusarium head blight in '93, mostly, again, fungicides have been fairly widely used on wheat. And here you'll see there's a couple of strips. There's one on the left side, there's another one further to the left of that screen, and the right side of the screen has been treated. And so the black strip, or the darker strip, there was basically the whole width of the sprayer was shut off by that grower. So he wanted to see what difference it would make to his wheat in terms of yield and in terms of quality. So this is anecdotal, but it's just to bring back some memories here a little bit. So the yield on the field on what was treated did 57 bushels to the acre back in 2000. The strips that he measured, there was two strips that he measured, this is about a half a mile long strips, did 42. So from 57 to 42, that's how much of a yield difference, the difference that was suffered. And here's a sample of the weeds that were treated on, the wheat heads treated on the right side and what was not treated on the left side. So they had premature death of the plants. It wasn't just Fusarium head blight, there's some other things going on there. There's some foliar leaf disease as well, but you can see how the heads turn black from some black mold. So anyway, so some pretty significant yield protection by this fungicide application that year on that variety. Just wanted to look back a little bit. There was a graph similar to that before. How cereals, back in about 25, 30 years ago, cereals were about 75% of the acres in the province, actually pretty much in Western Canada. The red, and that's the blue line. Now the sad side of the story is that it's a declining line. It's been down to below 40% in 2017. So cereals have really been taken a beat over the last few years. Oilseeds is the red line, has kind of kept its own, mostly due to canola there. And the bottom green line here is basically legumes or nitrogen-fixing plants or crops, and including soybeans. And before 2010, it was below 10%. That's how much legumes represented in the province. Since then, soybeans, as you probably most of you will know, have really dramatically increased until 2017, to the point now that, oilseed, the red line, is pretty much flattening out. And the cereals is mostly reflecting what's happening in the soybean or the legume crop types here. The upside here is that over the last 25, 30 years, as the wheat yields have gone up significantly. When I started back in 1988, the yield province-wide was only, it was below 20 bushels to the acre. That was a drought year. 1989 was also a drought year. Now, 2017 and 18 were also relatively drier years for most of the province. But look at the yield difference there. We're looking at about 3/4 of a bushel a year. That trend line is about 3/4 of a bushel per year over that period of time. So it's a good news story in that sense. In terms of variety grown in Manitoba, this is 2017 and 2018. AC Brandon dominates. In last year was 56% of the acres. This year was even higher at 65%, and that really dominates what the landscape in terms of the cereals. The good thing is it's a moderately resistant variety, fortunately, although we haven't had major problems with that Fusarium head blight in the last couple of years. This is a, excuse me, it's dry in here. This is the last 10 years summary of the Fusarium head blight survey that AAFC and Manitoba Agriculture, and I think industry contributes as well. In 2018, and the Fusarium head blight, it's a visual measurement of the disease in the field. So we look at 50 heads, we count how many heads have the disease, and then we also look at how severe that disease is on those heads. And we end up with, by multiplying the two, we have this index. So over the last 10 years, there was a 1.2% for the Fusarium head blight index. 2018 was 0.5, 17, 0.3, so again, two lower years. 2016 was really the last year we had significant problems with that particular disease. Anybody grew harvest in 2016? Raise your hand. Did you grow it last year or the last couple of years? Oh, you could, okay, yeah. Because there was a susceptible variety to that disease, and it took a hit that year. Anyway, so this is kind of an overview of that. I put this slide up here to show that Fusarium head blight is known most as a cereal disease. But if you look at this portion of the slide here, I'm not sure how well you can read that. I even have to put glasses on here. But the spore production here, it shows that the infection of pulses, oil seeds, and others can also impact the roots from some of those crops and in the crop residue as it breaks down, and spore production is released into the air. So even though if we have less cereals in the landscape, even other crops, material breaking down, and there can be some spores released into the atmosphere. So this is a slide basically that highlights the timing as to when a fungicide product should be applied. So we're not changing anything as far as that goes here today, but just to show, typically is when the head is fully emerged, or at least the majority of fully emerged, and the ideal time to spray is when some of those anthers are coming out in the middle of the heads, and that's the perfect timing. Okay, so just want to show, so the last 2 years, basically we've had two dry years, 2017 and 2018, and where we have red stars, we have 4 diversifications in Manitoba where Fusarium head blight trials have been done, and I'm going to run through some of those numbers here right away. First, the on-farm network, and this is done with the Manitoba Wheat and Barley Growers Association, as was mentioned before. So the on-farm trials use grower equipment for applying inputs and measuring yield. And what was done with those trials, there was an untreated check, recommended timing, and late timing to see what's happening. And the Fusarium head blight index is done 21 days after anthesis by a field crop pathologist. And the seed analysis for FDK or Fusarium damaged kernels and DON is done through an accredited lab. So this is just a quick layout here to show what a non-farm trial would look like, the protocol in the field. So we have a fungicide early anthesis, the proper timing, fungicide 3 to 5 days later, and then untreated checks. And that's replicated through the field so that we have statistical validation to these trials. So a little bit on 2017, the on-farm trial index to show there were 6 locations here, and the Fusarium head blight index. Again, this is a visual of what's happening in the field. So again, drier season. I don't know. Oh yeah, the varieties are listed there. So at each different site, most of the sites had Brandon as a variety, and I'm not exactly sure why this one here is at 4%. So it shows a fairly high level of Fusarium head blight index on that one. The recommended timing was much lower, and the late timing also as lower, and that seems to be fairly consistent across the different sites. In terms of yield, the on-farm trials here for those same locations, and I don't have statistics on that here particularly, but just to look at some of the averages, they're very close from one to the other, whether it's the recommended or late. We don't have a check here on this particular slide. 2018, again, this is there's a few trials done in 18 for the on-farm network, Elm Creek, Sperling, and so on. So you see the results there. So the untreated, the visual, this is Fusarium head blight index. The untreated was the highest consistently. And then the recommended and late were lower. So we can see an impact here of a fungicide application, even though it was a drier year as well in 2018. And this particular slide shows that in 18, Lariviere was the only trial with detectable Fusarium damaged kernels and DON levels. And even at that, the levels were quite low. Fusarium damaged kernel, go from a number 1 to a 2, you have to have at least, I think it's 0.25% Fusarium damaged kernel, or above that to kick it into a number 2, which would be to as high as 0.8. So again, you can see here the levels of FDK were low. DON's not really a grading factor. It was still determined, but it was still quite low here. 2018, okay, so this is the yield combined between the different sites here, and there were some differences here statistically. I guess it does show here some, but relatively close numbers in terms of yield, but between the late recommended and untreated. So then that would make sense that with the fungicide application would be better than an untreated, but again, the differences were not all that huge. So fungicide timing, and this is a summary here of what's happened here. This is at the Diversification Center, so there was 2 years of trials done. This is 2018 was year 2 of 2 years, and those were replicated and randomized. There was spring wheat varieties. There were 3 varieties used: AAC tenacious, which is a CPS, and the reason it was selected as a CPS because I think it's the only one with a R-rated for Fusarium head blight. AAC Brandon as a moderately resistant, hard red spring, and much more as a moderately susceptible variety. And there were 2 fungicide treatments: no fungicide as an untreated check, fungicide applied at anthesis, as I showed before, and a fungicide applied 5 days after anthesis to see again if there were some differences there in terms of timing. This is the 2017 yield data by variety and treatment. So again, fairly high yields in all cases here. No fungicide, tended to be somewhat lower than treated at the right time or later as well. Again, a dry year in 2017, and this is okay. And then if we look at the Fusarium head blight index, which is a visual in the field, although there's some numerical differences there, but the index was really quite low at 0.115, except for the one site there or the one variety, I should say, but still no statistical differences in that year for those. In terms of FDK or Fusarium damaged kernels by variety and site in 2017, with the different tenacious being the most resistant, much more the least resistant. We can see a general trend here, and even statistically some differences between those, but having the more resistant variety having the lower amounts of FDK in the sample. And this is FDK by treatment, by site, in Carberry, Melita, and so on. So here we see again, no fungicide, higher FDK by treatment, and with fungicide applications, even at the right time or a bit later, still a reduction, generally speaking here. 2017, the DON, which is the vomitoxin. very low level, typically below 0.8 is not much of an issue, at least that's what the local elevator tells me. It's not a grading factor, but we see here with the more resistant variety, we can still see a benefit. Again, the lowest level of Dawn versus AC Brandon, which is moderately resistant, and much more the moderately susceptible. So even in drier conditions, we can see some differences there measured. 2018 yield by variety site here. The statistics haven't been completely done, and I'm going to speak strictly on the Roblin side because Roblin was relatively wet in 2018. Now, out of 8 site years, that's the one that we had enough moisture to actually see some differences there. So the yield by variety, again, relatively high yields. We see as AC Tenacious, again, the most resistant. Brandon next, moderately resistant, and much more susceptible, moderately susceptible. The yield by treatment and site seems to be a bit of a trend here, except for the carberry site that typically with no fungicide have lower yield than with a fungicide, either at the right time or late timing. The Roblin site here, the yield, this is by variety and timing, again, Tenacious. Again, some yield differences there between the varieties, but we see a trend between the no fungicide again being lower than the proper timing or later timing as well. The Fusarium head blight index, because again it was wetter this past summer in that area. Again, AAC Tenacious seemed I'm not sure if there's no data or if it was 0, but AAC Brandon, it's a lower Fusarium head blight index with Brandon, even with a fungicide application, which doesn't quite make sense. Same with much more there, but we still see with lower resistance to the disease, Fusarium head blight index seems to be going up higher. The FDK, again, it's kind of the same story. More resistant varieties, we have less FDK. The Dawn, similar thing here. We see again more resistant. Actually, the Dawn here was relatively high at 1 parts per million, even with Tenacious, as high as 2 for much more. So in summary, again, cereal acreage has gone down dramatically over the last 30 years. The upside here is that wheat yields have increased dramatically over the last 30 years. Head blight remains still a production risk in Manitoba, but not a major factor the last 2 years. Wheat yields were high, but different small in terms of untreated check and so on. Using wheat varieties with best resistance, again, reading will help to reduce Fusarium head blight index, FDK, and Dawn compared to less resistant varieties, although there was not that much pressure the last 2 years. Applying a fungicide even later still was able to show some benefit of suppression of head blight, but again, limited data, 1 site year. And again, use an integrated approach to manage that disease is probably the best approach here. And lastly, future research, there is just to mention, there's a prairie-wide study looking at developing and validating a Fusarium head blight model in Manitoba and actually across Western Canada, and we're looking for cooperators for that if there would be some. And the University of Manitoba is leading this project, and that's it. Thank you. Sorry for the delay, it was tight.